Unit 1. Introduction. We studied before the numbers which were in the form of: first, number consists of one digit, once only, 0, 1, 2, up to 9. Number consists of two digits, ones and tens, 10, 11, 12, up to 99. Number consists of three digits, ones, tens, and hundreds. Number consists of four digits, and so on. One and larger numbers. Second, fractions. Fractions can have three different types. 1. Proper fraction. Example: half, 3 over 5, 9 over 14, and so on. The numerator is less than the denominator. 2. Improper fraction. Example: 3 over 2, 7 over 4, and 9 over 5, and so on. The numerator is greater than or equal to denominator. 3. Mixed fraction. Example: 2 and half, 3 and quarter, 5 and 3 over 8. A whole number and proper fraction together. Third, decimal numbers. Decimal fractions divide into decimal fraction. Example: 0.4, 0.921, and so on. Decimal number. Example: 3.1, 5.7, 19.5, and so on. Because of the different form of the numbers, it becomes necessary to study the sets to make classification and organization of these numbers, as we will see later. First, the set of natural numbers, and it's denoted by n. We use the set of arcs to write the set of the natural numbers. First, the set of natural numbers n equals 0, 1, 2, 3, 4, and so on. The dots mean that the numbers are continuous to infinity. So, all numbers which have been studied before belong to the set of natural numbers except decimal and normal fractions. Like you see, we can use the symbol belong. 3 belongs to n. 2 belongs to n, where this symbol read as belong to. So, 32 belongs to n. 147 belongs to n. 9, 465, 713, and 247 belong to n. We know that the natural numbers greater than or equals to 0, but we need to study the numbers under 0. For example, the temperature degrees in the cold regions, where the temperature 0 or under 0 in many times. Therefore, it became very necessary to add another new set of numbers, which are the negative numbers. Example: 3 greater than 0 by 3 units, and negative 2 is less than 0 by 2 units. The new set of numbers called the set of integers, and it's denoted by Z, which consists of integer numbers greater and less than 0, where Z equals to -3, -2, -1, 0, 1, 2, 3, and so on. The dots in the right side express the numbers greater than 3 and continues to infinity. And dots in the left side express the number less than -3 and continues to infinity. The relation between the sets. Z equals to the set of dots -3, -2, -1, 0, 1, 2, 3, and dots, and the set of -3, -2, -1 is Z negative, and 1, 2, 3, and dots denotes to the Z positive. Z positive is a subset of Z and expresses as Z positive subset of Z, and so Z negative subset of Z. This is illustrated in the figure. Other expression, we can say Z containing Z positive. We know that Z equals to dots -3, -2, -1, 0, 1, 2, 3, and dots. And we can represent integers on the number line. Each number has a fixed point on the straight line, the number line. The arrow drawn to the right side means continuity of Z positive to infinity. And the arrow drawn to the left side means continuity of Z negative to infinity. And the numbers arranged ascendingly from the smallest to the greatest in the direction from the left to the right. For example, 1 greater than 0 greater than -1. For example, 4 is greater than 3. 3 is greater than 2. 2 is greater than 1. 1 is greater than 0. 0 is greater than -1. -1 is greater than -2. -2 is greater than -3. -3 is greater than -4. Operations on the sets. First, intersection. The set of common elements in the two sets, we use the symbol intersect to express intersection. Example, X equals a set of 0, 1, 3, and 5. Y equals a set of 3, 5, and 9. Then X intersects Y equals to the set of 3 and 5. General case. N intersect Z positive equals Z positive. N intersect Z equals N. Second, union. We use the symbol union to express union. The set of all numbers which belong to two sets. Example, X equals a set of 0, 1, 3, and 5. Y equals to the set of 3, 5, and 9. Then X union Y equals to the set of 0, 1, 3, 5, and 9. General case. N union Z negative equals to Z. Z positive union a set of 0 union z negative equals to z. The third, difference. Difference of two sets is a set whose elements belong to the first set but don't belong to the second set. We use the symbol difference to express the difference. Example, x equals to set of 0, 1, 3, and 5. Y equals to set of 3, 5, and 9. Then, x difference y equals to the set of 0 and 1. Y difference x equals to the set of 9. General case. N difference the set of 0 equals to z positive. Z difference n equals to z negative. Remark. There is no repeating to any element of the set. Repeated power. When we analyze the number 32 to its initial factors, we found that 32 equals 2 times 2 times 2 times 2 times 2. That means the number 2 is repeated 5 times in multiplication operation, and instead of writing the number 32 equals 2 times 2 times 2 times 2 times 2, we can write it as 2 to the power 5, where the number 2 is called the base and the number 5 is called the power or exponent. Negative 2 to the power 5 is reading as negative 2 to the power 5 or negative 2 to fifth power. Example, 3 to the power 4 equals 2, 3 times 3 times 3 times 3. 7 to the power 2 equals to 7 times 7. Remark. Repeated multiplication. Number 1. The base which has exponent of 2 is called square number. Example, 0 equals to 0 power 2. 1 equals to 1 power 2. 4 equals to 2 power 2. 9 equals to 3 power 2. So, the numbers 0, 1, 4, 9, and so on are called square numbers. Two, the base which had exponent of 3 called cubic number. Example, 0 equals to 0 power 3. 1 equals to 1 power 3. 8 equals to 2 power 3. 27 equals to 3 power 3. So, the numbers 0, 1, 8, 27, and so on are called the cubic numbers. 3. For every number except 0 has exponent of 0, its value equals to 1. 5 to the power 0 equals to 1. 3 to the power 0 equals to 1. 7 to the power 0 equals to 1. And 2 to the power 0 equals to 1. The absolute value shows the number line that the number of units that represent the distance between 0 and the number 4 is 4 units in positive direction. The number of units that represent the distance between 0 and the number -4 is 4 units in the negative direction. That means the number of units between the number 4 and 0 is called the absolute value of the number 4, and the number of units between the number -4 and 0 is called the absolute value of the number -4. The absolute value of 4 equals to the absolute value of the number -4, and the absolute value of any number is denoted by the symbol as you see. Absolute value of 4 equals to 4, and the absolute value of -4 equals to 4. The set of rational numbers. Q. Example 1. Khalid has 15 pounds and Hussein has 20 pounds. Find the ratio between them. Solution. The ratio between Khalid to Hussein equals to 15 pounds to 20 pounds. 15 to 20. We can divide by 5. Then we have 3 to 4. So the ratio equals to 3/4. The number 3/4 called defined as rational number. Remark. 3/4 equals 0.75. So 0.75 called rational number. The rational number is a number that can be expressed in the form of ratio. Example 2. Shahd and Nada love eating apples one day. Shahd eats 2 apples and Nada eats 6 apples. Solution. The ratio between what Shahd eats and what Nada eats equals 6 apples to 2 apples. Equals to 6 to 2. Dividing by 2 equals 3 to 1. The number 3/1 called rational number. The number 3/1, so 3 is rational number. The rational number can be expressed in the form a/b, where a and b are integers, and b not equals to 0. Definition of the rational number. It is the number that can be expressed in the form a/b, where a and b are integers and b not equals to 0. The set of rational number q equals to x, where x equals a/b, and a belongs to z, and b belongs to z, and b not equals to 0. For example, the rational numbers half, 7/3, -5/4, -2/9, 2.4, 0, 8, and -4, and so on. Remark. 2/0, -9/0, 0/0, don't express rational number. Division by 0 is meaningless. The set of the natural numbers. We know that n equals the set of 0, 1, 2, 3, 4, and so on. 0 equals 0/1. 1 equals 1/1. 2 equals 2/1, and so on. So, any natural numbers can be written in the form of a common fraction of the denominator equals 1. So, each natural number is a rational number with the denominator 1. The set of integer numbers. We know that z equals the set of -3, -2, -1, 0, 1, 2, 3, and so on. Since any integer number can be written in the form z equals the set of -3/1, -2/1, -1/1, 0/1, 1/1, 2/1, 3 over 1, and so on. So each integer is a rational number. N, subset of Z, subset of Q. Representing rational number on the number line. A. Represent the rational number A over B, where B equals 2. B. Represent the rational number A over B, where B equals 3. Represent the rational number A over B, where B equals 4.
Unit 2, Lesson 1. First, algebraic terms. The algebraic term consists of two factors or more. Example, 3x equals to 3 times x. 3x is the algebraic term. 3 numerical factor. X simple factor. 3 is called coefficient. Negative 6a squared equals to negative 6 times a times a. We have 3 factors. Negative 3xy squared equals negative 3 times x times y times y. 4 factors. 5 equals 5. 1 factor is called free term or absolute term. Degree of an algebraic term. The degree of an algebraic term is the number of simples of it. Example, 5 is of 0 degree. 3x is of the first degree. 6a squared is of the second degree. 3x squared y is of the third degree. Remark, if an algebraic term is only a numerical factor, then it's called a free term or absolute term. Algebraic expression. The algebraic expression consists of two terms or more. Example, 3x plus 5y, 2 terms. 2a squared b plus 3ba cubed, 2 terms. Negative 5 lm plus 6l squared m minus 7, 3 terms. Degree of the algebraic expression. The degree of an algebraic expression is the degree of the highest degree of any term of it. 3x plus 5y is of the first degree. 2a squared b plus 3ba power 3 is of the fourth degree. 5lm plus 6l squared m minus 7 is of the third degree. Example 1. Arrange the following expressions. 3a power 3b power 3 minus 2a squared b squared plus 5ab plus 7. I in ascending order to the power of a. Double i's in ascending order to the power of b. And write the degree. Solution. I. 7 plus 5ab minus 2a squared b squared plus 3a power 3b power 3. Double i's. 7 plus 5ab minus 2a squared b squared plus 3a power 3b power 3 is of the sixth degree. Example 2. Arrange the following expression in ascending order and descending order to the power of x. 2x squared y power 3 plus 3y squared minus 5yx minus x power 3. Solution. Ascending. 3y squared minus 5yx plus 2x squared y power of 3 minus x power of 3. Descending. Negative x power of 3 plus 2x squared y power of 3 minus 5yx plus 3y squared. Unit 2, Lesson 2. The like terms. Like terms have the same symbols and same powers. Example, 5x squared, negative 3x squared, negative half x squared are like terms. 5x, negative 3x squared, 4x power 3 are not like terms. Simplify the following. A. 3m minus 51 minus m plus 21. Solution. 3m minus m plus 21 minus 51 equals to 2m minus 31. B. 5b minus 3b squared plus 4 minus 7b squared minus 6b minus 1. Solution. 5b minus 6b minus 3b squared minus 7b squared plus 4 minus 1 equals negative b negative 10b squared plus 3. 2m minus 3l. We cannot add the unlike terms as we know. Unit 2, Lesson 3. Multiplying the algebraic terms. Example. Find the following. A. 5a times 3b. B. 7x times negative 2. C. 6x squared times 3y squared. D. 3x squared y times negative 4xy squared. Solution. A. 5a times 3b equals 15ab. B. 7x times negative 2 equals negative 14x. C. 6x squared times 3y squared equals 18x squared y squared. D. 3x squared y times negative 4xy squared equals negative 12 x power 3 y power 3. Divide algebraic term by another term. Remark. When we divide the same basis, we write a base and subtract the powers. Example. Find the following. A. 9a to the power 5b to the power 4 divide 6a to the power 3b. Answer. A. 9 over 6 times a to the power 5 over a to the power 3 times b to the power 4 over b to the power 1 equals 3 over 2 a squared b cubed, or 9a to the power 5 b to the power 4 over 6a to the power 3 b equals 9 over 6 a squared b cubed. B. 8x to the power 4 y to the power 3 divide negative 4xy squared. The answer. 8x to the power 4 y to the power 3 over 4xy to the power 2 equals negative 2 x to the power 3 y. C. Negative 52 m to the power 3 divide by negative 13 m squared. The answer. Negative 52 m to the power 3 over negative 13 m to the power 4 equals 4m. D. Negative 36 L squared n to the power 3. Divide negative 4 L squared n. The answer, negative 36 L to the power 2 n to the power 3 over negative 4 L squared n equals 9. Unit 2, Lesson 4. First, adding algebraic expressions. Example, add the following expressions. A, 3x minus 2y plus 5 and x plus 2y minus 2. Solution, horizontal method. 3x minus 2y plus 5 plus x plus 2y minus 2 equals 3x plus x plus 2y minus 2y plus 5 minus 2 equals 4x plus 0 plus 3 equals 4x plus 3. B, 2a squared b minus 3ab squared plus b cubed and minus a squared b plus b cubed. Solution, 2a squared b minus 3ab squared plus b cubed plus negative a squared b plus b cubed equals 2a squared b minus a squared b minus 3ab squared plus b cubed plus b cubed equals a squared b minus 3ab squared plus 2b cubed. C, 5x plus 2y minus z plus 2, 7x plus y minus 3z plus 3, and negative 2x minus 5y plus 4z minus 1. Solution, vertical method. 5x plus 2y minus z plus 2, 7x plus y minus 3z plus 3, negative 2x minus 5y plus 4z minus 1. The answer is 10x minus 2y plus 0 plus 4 equals 10x minus 2y plus 4. Second, subtracting algebraic expressions. Example, number 1. Subtract 2a plus 6b minus 7 from 2a minus 7b plus 2. Solution, horizontal method. 2a minus 7b plus 2 minus 2a plus 6b minus 7 equals 2a minus 7b plus 2 minus 2a minus 6b plus 7 equals 2a minus 2a minus 7b minus 6b plus 2 plus 7 equals 0 minus 13b plus 9 equals negative 13b plus 9. Vertical method. 2a minus 7b plus 2 minus 2a minus 6b plus 7. The answer, 0 minus 13b plus 9. Example, what is the increase of 5x squared minus 3xy plus y squared, then 3x squared minus xy minus 2y squared? Solution, horizontal method. 5x squared minus 3xy plus y squared minus 3x squared minus xy minus 2y squared equals 5x squared minus 3xy plus y squared minus 3x squared plus xy plus 2y squared equals 5x squared minus 3x squared minus 3xy plus xy plus y squared plus 2y squared equals 2x squared minus 2xy plus 3y squared. Example, what is the decrease of 2a squared minus 3ab minus 5b squared than 4b squared plus 3a squared plus ab? Solution. Vertical method. 4b squared plus 3a squared plus ab, negative 5b squared, change it into positive 5b squared, plus 2a squared, change it into minus 2a squared, minus 3ab, change it into positive 3ab. Then we have 4b squared plus 5b squared equals 9b squared, and 3a squared minus 2a squared equals 1a squared, and ab plus 3ab equals 4ab. Example, what is the expression should be added to 2l minus 3l squared plus 5 to equal 6 plus l squared minus l? Solution. Horizontal method. L squared minus l plus 6 minus negative 3l squared plus 2l plus 5 equals to a squared minus l plus 6 plus 3l squared minus 2l minus 5 equals to l squared plus 3l squared and negative l minus 2l plus 6 minus 5 equals 4l squared minus 3l plus 1. Vertical method. L squared minus l plus 6 plus 3l squared minus 2l minus 5. Then we have 4l squared minus 3l plus 1. Unit 2, Lesson 5. Multiplying algebraic expression by the algebraic expression. Example. Find the following. 5 open bracket a minus 3. B. 3x open bracket x plus 5. C. Negative 2a open bracket 7 minus 3a. D. Negative 14a plus 6a squared. D. 3x times 2x squared minus 3x times x minus 3x times 5 equals 6x power 3 minus 3x squared minus 15x. Unit 2, Lesson 6. Multiplying algebraic expression of two terms by another. 1. Horizontal. 2. Vertical. 3. Direct multiplication method. Example 1. Find the following. 3a plus 2 times 2a plus 5. Solution. Number 1. The first method. 3a times 2a plus 5 plus 2 times 2a plus 5 equals 6a squared plus 15a plus 4a plus 10 equals 6a squared plus 19a plus 10. 2. The second method. 3a plus 2 times 2a plus 5. Then 2a times 3a equals 6a squared, and 2a times 2 equals 4a, and 5 times 3a equals 15a, plus 5 times 2 equals 10. Then by adding, we have 6a squared plus 19a plus 10. 3. The third method. 3a plus 2 times 2a plus 5. Then 3a times 2a plus 3a times 5 plus 2 times 2a plus 2 times 5 equals 6a squared plus 15a plus 4a plus 10 equals to 6a squared plus 19a plus 10. Example 2. Find the following. 2x minus y times 2x plus y minus 2x squared minus y. Solution. First times first minus second times second. Then 2x times 2x minus y times y equals 2x squared minus y squared plus y. Example 3. Find the following. 3x times 2x minus 5y times 2x plus 5y. Solution. 3x times 4x squared minus 25y squared equals 12x power 3 minus 75xy squared. Example 4. Simplify the following. 2x minus y times 2x plus y minus x squared minus 2y squared. Solution. 4x squared minus y squared minus x squared plus 2y squared equals 4x squared minus x squared minus y squared plus 2y squared equals 3x squared plus y squared. We note that the two expressions have like terms except the sign of the second that Example 5. If a equals b plus 3, write the expression a squared plus 5a plus 2 in terms of b. Then simplify it into the simplest form. Solution. A squared plus 5a plus 2 equals b plus 3 all squared plus 5b plus 3 plus 2 equals b squared plus 6b plus 9 plus 5b plus 15 plus 2 equals b squared plus 6b plus 5b plus 9 plus 15 plus 2 equals b squared plus 11b plus 26. Example 6. If L equals x plus y and n equals x minus y, write the expression 3L squared plus m squared in terms of x and y, then simplify it. Solution. 3L squared plus m squared equals 3x plus y all squared plus x minus y all squared equals 3x squared plus 2xy plus y squared plus x squared minus 2xy plus y squared equals 3x squared plus 6xy plus 3y squared plus x squared minus 2xy plus y squared equals 3x squared plus x squared plus 6xy minus 2xy plus 3y squared plus y squared equals 4x squared plus 4x plus 4y squared. Example 7. Find the following. 3x plus y all squared. Solution. The first method. 3x times 3x plus 2 times 3x times y plus y times y. Then 9x squared plus 6xy plus y squared. The second method. 3x plus y times 3x plus y. 3x times 3x equals 9x squared. 3x times y equals 3xy. And y times 3x equals 3xy. And then y times y equals y squared. Then by adding, we have 9x squared plus 6xy plus 3xy equals 6xy plus y squared. The third method, 3x plus y all squared equals 3x all squared plus 2 times the first times the second. It means 2 times 3x times y plus the second square, which is y squared. Then we have 3x squared equals 9x squared, and then 2 times 3 equals 6 and xy, then we have 6xy plus y squared. Unit 2, Lesson 7. Dividing algebraic expression by algebraic term. In the opposite figure, a rectangle of 3 parts, and we know the area of the rectangle is L times W. Area of the rectangle equals L squared plus LM plus LM equals to L squared plus 2LM. Width of the rectangle is L. The length of the rectangle equals area divided by width. Then L squared plus 2LM divided by L equals L squared divide L plus 2LM divide L equals to L plus 2M. And L plus 2M is the length of the rectangle.
Dividing an algebraic expression by another algebraic expression. We can multiply x plus 2 all time x plus 3. The result is x power 2 plus 5x plus 6. Also, we can divide x squared plus 5x plus 6 divided by x plus 2. The result is x plus 3 and is written as x squared plus 5x plus 6 as a bracket divided by x plus 2 equals x plus 3. X squared plus 5x plus 6 is called dividend. X plus 2 is called divisor. X plus 3 is called quotient. We can also represent the divisor on the opposite figure. Find the quotient of the algebraic expression squared x minus 3x minus 10. Divide by x plus 2. Solution. Step number 1. We have to put the dividend and the divisor as you see. Step number 2. We have to divide the first term, which is greater power, by the first term in the divisor. Then multiply x by the divisor, then the result becomes x squared plus 2x. Step number 3. Subtracting squared x plus 2x from the dividend means change the sign, then add the result becomes negative 5x. Put negative 10 beside it. Step number 4. We have to repeat the last steps by dividing negative 5x, which has the greatest power, by x in the divisor. The quotient is negative 5. We have to multiply negative 5, the divisor. The result will be negative 5x minus 10. Step number 5. we have to subtract as we did before. Change the sign of the algebraic expression negative 5x minus 10 to be 5x plus 10. Then, by adding the left is 0. Step number 6. Then the quotient is x minus 5. Before the division operation, note rule number 3. Find the quotient of the algebraic expression x squared minus 9 divided by x minus 3. Solution. Step number 1. We have to put the dividend and the divisor in the form of the division, and we have to let space stands for x. Step number 2. We have to divide the greater power 2x in the dividend by x raised second to the high power in the divisor. It becomes x, then multiply by the divisor. Step number 3. By subtracting squared x minus 3x from the divisor, by changing the sign, then by adding the result is 3x, put negative 9 besides it. Step number 4. We have to repeat the same steps by dividing x with the greatest power result by x raised to the greatest power in the divisor. It becomes 3. We have to multiply again. It becomes 3x minus 9 down 3x minus 9. Step number 5. By subtracting means change the sign, then by adding the result it will be 0. Step number 6. Then the quotient is x plus 3.
Factorization by taking out HCF. We know that the distribution of multiplying and adding and subtracting in Q. If 5 times 7 plus 5 times 4, then we can take out 5 as a common factor, 5 times 7 plus 4. And if we have 6 times x plus 6 times y, then we can take 6 as a common factor, then we have 6 times x plus y. And if ax plus ay, then a take it as a common factor out, then we have a open bracket x plus y. Number 1. Factorizing by taking out HCF of coefficient. Example 1. Factorize 10a plus 15b plus 25c. Solution. The highest common factor HCF of the coefficient is 5. So 5 open bracket 10a over 5 plus 15b over 5 plus 25c over 5. Then 5 open bracket 2a plus 3b plus 5c. Factorizing by taking out HCF of symbols. Example 2. 7x power 3 minus 6x squared plus 5x. Solution. The highest common factor of symbols is x to the least power. Then x out and open bracket 7x power 3 over x minus 6x squared over x plus 5x over x. Then we have x open bracket 7x squared minus 6x plus 5. Factorizing by taking out HCF of coefficients and simples. Example 3. Factorize 3a squared b power 3 minus 9a power 3 b power 4 plus 12a power 3 b squared. The highest common factor of the coefficients is 3, and the highest common factor of the symbols is a squared b squared. Then the solution will be like 3a squared b squared, open bracket, 3a squared b power 3 over 3a squared b squared, minus 9a power 3 b power 4 over 3a squared b squared, plus 12a power 3 b squared over 3a squared b squared, equals 3a squared b squared. Inside the bracket we have b minus 3ab squared plus 4a. Sometimes we get the highest common factor in algebraic expression. Example 4. Factorize x, open bracket a plus b, plus y, open bracket a plus b. Solution. The highest common factor is a plus b. So we have a plus b times x plus y. Double eyes. A minus b times a plus 3b plus 2a times a minus b. Solution. HCF is a minus b. Then a minus b times a plus 3b plus 2a equals to a minus b times 3a plus 3b equals 3a minus b times a plus b.
Statistics. Reading and interpreting data. Number 1. Bar charts. 2. Line graphs. 3. Pie charts. Collecting and organizing data. Representing data. The mode, the median, the mean. Read the script without reading the answers. Drill 1. The opposite figure shows the highest and the lowest temperatures in some given rates in one day. Complete the following using the chart. A. The greatest highest temperature is what given rates? B. The smallest lowest temperature is what given rate? C. The difference between the highest temperature in Cairo and Matruh is what degrees? D. The difference between the highest and lowest temperature in Sohaj is what? E. The lowest temperature is equal in both of Drill 2. The following table shows the number of pupils in 4 rows. The first row 20 pupils. The second row 30 pupils. The third row 40 pupils. The fourth row 50 pupils. The opposite bar chart shows the percentage of the boys and girls in these 4 rows. Find A. Number of girls in the first row. B. Number of boys in the third row. C. Number of girls in the fourth row, then find number of boys. Solution. A.
The percentage of girls in the first row is 40%. The total number of pupils is 20. Then, number of girls in the first row equals 40 over 100 times 20 equals 8 girls. B. The percentage of boys in the third row is 20%. The total number is 40 pupils. Then, number of boys is equal to 20 over 100 times 40 equals 8 boys. C. The percentage of girls is 30%. Number of pupils is 50. Then, number of girls equals 30 over 100 times 50 equals 15 girls. Number of boys equals 50 minus 15 equals 35 boys. Drill. The following table shows the marks of Murad in math exams for 5 months. In September, 30 marks. October, 40 marks. November, 35 marks. December, 42 marks. January, 50 marks. Draw the line graph representing it and write a suitable title. Complete the following. We draw 2 scales. The horizontal represents months and the vertical represents marks. Note that it's not necessary to begin with 0, but to know what are the smallest and the greatest numbers is good for you to determine your scales. Pie charts. What's pie chart? The pie chart is a part of the circle surface, lies between 2 chords and an arrow in it. Pie chart is the meaning of comparing data, especially when it is given in percentage. For example, comparing between the earth and water, we observe that water is greater than the earth. Example. The following table shows the numbers of pupils in 3 rows of the prep school. First row is 45 pupils. Second row is 40 pupils. Third row is 35 pupils. Represent these data using pie chart. Solution. We determine the total number of pupils, which is 120 pupils. We determine the angles measure of the pie chart, which equals number of pupils over their total number times 360 degrees. So, the sector of the first row equals 45 over 120 times 360 degrees equals 135 degrees. The sector of the second row equals 40 over 120 times 360 degrees equals 120 degrees. The sector of the third row equals 35 over 120 times 360 degrees equals 105 degrees. Drill. Complete the following table, which shows the percentage of the components in making cakes. Component and percentage. Milk, 10%. Sugar, 25%. Flour, 50%. Butter, 15%. Represent these data using pie chart. Solution. Notes that the total sum is 100%. So, percentage of butter equal 100% minus 10% plus
25% plus 50% equals 100 minus 85 equal 15%. The scepter of milk equals 10 over 100 times 360 equals 36 degrees. Sugar equals 25 over 100 times 360 equals 90 degrees. Flour equals 50 over 100 times 360 equals 180 degrees. Butter equals 15 over 100 times 360 equals 54 degrees. Drill. A. Calculate the center angles of each sector of the pie chart of the number of tourists from year 2003 to 2005. Write the values in the appropriate table. B. Use the values for the angles to draw the sectors of a pie chart for number of tourists from 2003 to 2005. C. Complete the data on each sector and put a suitable title to the drawing. D. Complete the data on each sector and put a suitable title to the drawing. 2003. 188 Americans represents 3.1%. 1,322 Arabs represents 21.9%. 4,204 Europeans represent 69.05%. 331 other nationalities represent 5.5%. So the total 6,045, 100%. The measure of the angle equals percentage over 100 times 360 degrees. Collecting and organizing data. We need to collect data through organizing to help us to make right decision. There are three different types of data. Number one, primary data. Data collected using the observation sheet or questionnaire. 2. Secondary data. Data collected from sources like internet, documentaries, scientific references, and other publications. 3. Experimental data. Data collected by doing an experiment to test a theory. Definition. Questionnaire. A tool for getting observation of people or things or events can be observed, such as values, behavior, opinions. The questionnaire is designed by a specialist and includes, number one, data about persons like age, level of education, gender, employment. 2. The questions may be optional. 3. Necessary question. A. Close the questions with choices like do you practice sports? Run, swim. The answer yes or no or sometimes. B. Open questions that express the people's opinions like write your opinion on solving the housing problem. Organizing data. The simplest method is using the Tolly charts. Example. The data shown below is average of temperature degrees during last December in one of the Egyptian governorates. 22, 23, 24, 25, 24, 20, 21, 22, 23, 25, 24, 22, 23, 23, 23, 23, 24, 23, 22, 23, 24, 23, 20, 19, 20, 22, 25, 23, 22, 21. Determine the minimum temperature degree, which is 19, and the maximum temperature degree, which is 25. The difference between them is 6 degrees. This difference between the maximum value and the minimum value is called the range. From the totally charts table, temperature degrees: 19, 20, 21, 22, 23, 24, 25. Totally charts: 1, 3, 2, 6, 10, 5, and 3. Frequencies: 1, 3, 2, 6, 10, 5, 3. And by omitting the row of the toilet charts, we get the following frequency table. Temperature degrees: 19, 20, 21, 22, 23, 24, 25. And the total. Frequencies: 1, 3, 2, 6, 10, 5, 3. The total is 30. We did use the following information by noticing the previous table. The minimum temperature degree is 19, and it was in one day only in this month. Pictorials. We can use some figures. Pictorials as a statistical science. For example, the following table expresses the number of pupils in the 3 grades in preparatory school. Each star expresses 50 pupils. Grade 7, 5 stars. Grade 8, 4 stars. Grade 9, 5 stars. Then grade 7, 250. Grade 8, 200. Grade 9, 200. Representing data. First, the mood. The mood is one of the measures of the central tendency. Definition. The mood of a set of values is the most common value. Example 1. Find the mood of each of the following. Number 1. 5, 8, 7, 5, 9, 8, and 5. 5 is the mood. 2. 6, 5, 7, and 6. 6 is the mood. 3. 3, 6, 10, 13, 19, 19, and 21. 19 is the mood. Example 2. At the mood of the values 4, A, 5, and 3 is 3. So what the value of A? The value of A is 3. B. At the mood of the values 12, 7, x plus 1, 7, and 12 is 7. Then the value of x is what? The value of x is 6. The mood from the frequency table. Example. The following frequency table shows the salary of 40 workers in a factory on working day. From this table, find the mode of the salary. The mode of the salary is 18. This salary of the greatest number of workers. Draw. 40 students were survived about the number of books they had read in a year. This raw data was obtained using the following table to form the frequency table. Then find the mode number of books. Second, the median. The median is one of the measures of the central tendency. Definition. The median of a set of values is the value which divides this set such that the number of the values which are greater than it is equal to the number of the values which are less than it, after arranging these values ascendingly or descendingly. To get the median, do as follows. Number 1. Arrange the values ascendingly or descendingly. If the number of values is odd, then the median is the value median is in the middle exactly. For example, if the values are 4, 17, 8, 6, and 10, then its ascending order is 4, 6, 8, 10, and 17. So the median equals 8. If the number of values is even, then the median equals the sum of the two middle values over 2. For example, if the values are 2, 5, 5, 6, 7, 9, 11, 14, 16, and 21, then the median equals 9 plus 7 over 2 equals 8. Third, the mean. The mean is one of the measures of the central tendency. Definition. The mean of a set of values equals sum of these values over number of these values. Example 1. Calculate the mean of the following values: 5, 8, 3, 7, 6, and 1. The mean equals 5 plus 8 plus 3 plus 7 plus 6 plus 1 over 6 equals 30 over 6 equals 5. The mean of a set of values of iterative distribution. Example. The following table shows the distribution of salaries of 20 workers in a factory. Salary by LE. Solution. The sum of salaries is 15 times 2 plus 20 times 3 plus 22 times 5 plus 23 times 5 plus 25 times 1 plus 30 times 4 equals 30 plus 60 plus 110 plus 115 plus 25 plus 120 equals 460 LE. So the mean equals sum of salaries over number of workers equals 460 over 20 equals 23 LE.
Unit 1. Introduction. We studied before the numbers which were in the form of: first, number consists of one digit, once only, 0, 1, 2, up to 9. Number consists of two digits, ones and tens, 10, 11, 12, up to 99. Number consists of three digits, ones, tens, and hundreds. Number consists of four digits, and so on. One and larger numbers. Second, fractions. Fractions can have three different types. 1. Proper fraction. Example, half, 3 over 5, 9 over 14, and so on. The numerator is less than the denominator. 2. Improper fraction. Example, 3 over 2, 7 over 4, and 9 over 5, and so on. The numerator is greater than or equal to denominator. 3. Mixed fraction. Example, 2 and half, 3 and quarter, 5 and 3 over 8,